Assalamualaikum to panels and my supervisor. My name is Ahmad Shafiq bin Romat with number metric 221092172, and I'm pleased to present my final year project entitled Modeling and Simulation of Switching Transients in Circuit Breaker for High Voltage Systems, HV24. The main tools for my project is circuit breakers, which circuit breakers can affect the voltage and current waveform in high voltage systems, especially focusing on a phenomenon known as transient recovery voltage (TRV), where the driver is a critical aspect that influences the performance and reliability of circuit breakers. Based on my project title, there are two objectives. The first objective is to model and simulate switching transients during circuit breaker operations in high voltage systems using ATP Draw software. And the next objective is to analyze the transient recovery voltage (TRV) of the circuit breaker based on IEEE standard for different switching conditions. Next is the demonstration of tool applications based on the title Modeling and Simulation of Switching Transients in Circuit Breaker for High Voltage Systems. For result, there are three cases for my project, where the case 1 and case 2 is to simulate switching transients of circuit breaker under load conditions, and case 3 under fault conditions. Each of the cases have two different scenarios, where each scenario selecting time switch operating is selected by refer lowest and highest point voltage under steady state conditions. For case 1 and case 2, switch closing time is -1 second, and switch opening time for both scenario is set to 0.04 seconds and 0.045 seconds. For scenario 1, case 1, after the time reached 0.04 seconds, the switch operating changed from closed condition to open conditions immediately. The peak voltage after interruptions of current reached 5.5 kV. For scenario 2, the circuit breaker delayed the operation until the current reached the next zero. This is to minimize the effect of arcing and insulation failure to the system. For case 2, scenario 1 with setting of circuit breaker switch opening time 0.04 seconds. The current and voltage interactions happens at zero closing where the TRV is observed. The spike voltage after interruption reached 10 kV where the circuit system usually operate at 6.6 kV at steady state conditions. For scenario 2, which is the highest point of voltage, the circuit breaker delayed the open condition operations approximately at 0.55 seconds, where at 0.55 seconds is the next zero closing for current. The delays of operation is to minimize arcing and insulation failure of the system. The TRV occurs after the current interruptions where the peak voltage is similar with scenario 1. For case 3, the main circuit breaker setting of switch closing time is set to -1 second, and the circuit breaker 2 setting for both scenario 1 and 2 is similar, which is the switch closing time is set to 0.04 seconds and switch opening time is set to 1 second. The different setting for both scenarios is the main circuit breaker, where the switch opening time selected based on the lowest and the highest point of voltage at steady state conditions after the fault occurs at phase A. For scenario 1, the setting for switch opening time of main circuit breaker is set to 0.08 seconds, which is the lowest point of voltage for steady state conditions. At 0.04 seconds, the fault occurs because the circuit breaker 2 switches operation is changed from open into closed condition. At fault, the peak of current phase A reached 6.6 kA. When reached 0.08 seconds, which is the setting of main circuit breaker of switch opening time, the fault is clear and the TRV is observed. The peak of TRV approximately at 17 kV, where in steady state conditions, the system steady state is running at 12 kV. For scenario 2, the setting of the main circuit breaker switch opening time is set to 0.085 seconds, which is the highest point voltage at steady state conditions. After fault occurs at 0.04 seconds, the main circuit breaker clears the fault by opening the main circuit breaker at 0.085 seconds. The circuit breaker operations is delayed because the breaker open condition usually happens at zero crossing of currents. This is to minimize the component stress and insulation failure in the systems. There are three tool limitations for this project, which the first one is idealized switching mechanisms. ATP draws software models circuit breaker as idealized switches with predetermined opening and closing times. However, real circuit breakers experience mechanical relays, contact bounce, and arc extension dynamics that factors that are not fully represented in ATP draw software simulations. The second limitation is lack of real-time dynamics, where the tool operates in a time-step simulation mode and does not support a real-time hardware in the loop, which for the example is temperature, moisture, or aging, which can affect installation performance. The last limitation is limited user interface and documentations, where the steep learning curve with limited documentation and no commercial support, making it challenging for the beginners. For conclusion, successful simulation of switching transients and understanding TRV behavior, where it gained insight into TRV characteristics during circuit breaker operations, especially during current interruptions. The TRV is observed that influenced by the system parameters like voltage level, inductance, and capacitance. Transients behavior during circuit breaker operations was clearly visualized under various conditions, including load switching and fault interruptions. The TP-DROS role in the system analysis, where the software is proved valuable for investigating the dynamic response of power system components during transient events. It also helped highlight the potential stress points in the system that could affect stability and equipment reliability.